Okay, so next we're going to start chapter 3, which is going to be about data description. And our first section is going to be all about measures of central tendency. So central tendency is basically going to give us a way of answering the question, how do we describe the center of the data? Okay, so we want to look at ways that we can answer or describe where the center of the data is. So just a couple definitions first before we start. A statistic is a characteristic or measure obtained by using the data values from a sample. And a parameter is a characteristic or measure obtained by using all of the data values from a specific population. So technically, when we're talking about data from a sample, we should be using the word statistic. And when we talk about data from a population, we should be using the phrase parameter. But really not a big deal if you mix those up. An easy way to remember it, though, is that S goes with S and P goes with P. So statistic, sample, parameter, population. As far as rounding throughout this entire semester, it is going to change. Like the rule for rounding will change throughout pretty much every section and chapter. For this chapter, though, when we round, we're going to typically round to one more decimal place than the data. Okay, so our first measure of central tendency is called the mean, and the mean is the sum of values divided by the total number of values. I'm just going to move this. Okay, so in statistics, when we talk about the mean, we're going to use different symbols depending on whether it's the mean of a sample or the mean of a population. So the sample mean, we use the symbol X bar. So that's an capital X with a bar over it, and you just read that as X bar. That stands for the sample mean. If you look in these formulas here, you'll see this Greek letter sigma. That just stands for sum. So that just is telling you to add up all of those values. And then for population mean, we're going to use the Greek letter mu. So X bar goes with the sample, mu goes with the population. And then whether you see a lowercase n or a capital N throughout this entire semester, that's just always going to stand for the total number of data values. Okay, so let's look at an example. So example 1 says that the data shows the number of patients in a sample of 6 hospitals, I think it actually should be 8 hospitals, who acquired an infection while hospitalized, and we want to find the mean. Okay, so long story short, all we have to do is add all those up and divide by how many there are. But let's go ahead, let's get comfortable with our notation. So I'll jot that down as well. So X bar, our sample mean, is going to be equal to the sum of all of the X's divided by N. So if you add all those numbers up, you'll get 443. And there are 8 of them, so you divide by 8, and that comes out to 55.4. Now this data set was fairly simple, so that's easy to do by hand. If you come across on Connect Math some larger data sets, it is helpful to actually use your graphing calculator to calculate this. So I'm going to show you guys how you can do that in your calculator. So we want to use the list function. And let me pull up a calculator and I'll show you where that is. Okay, so whether you have the 83 calculator or if you're using an 84 or the online 84 one, looks just like this. If you click the stat button, I'm going to do it on mine here. So if you click stat and then enter on the word edit, that's going to bring you to a bunch of lists where you can plug data sets in. So click stat, enter, and then go ahead and put these 8 values into L1. And then once you have that, you're going to click stat and then arrow over to calc. That stands for calculate. And then we want the one that's right on top. So your cursor will already be there. It's called one variable statistics or one bar stats. So just click enter on that. And then depending on the calculator that you're using, you're going to see one of 2 inputs here. So if you have the 83 model, it's going to put one var stats up on your home screen, and then you have to now tell it what list to use. So once it pops up one var stats, then you're going to click second and then the 1, and that's going to type in L1 there. So second 1, and then press enter, and you should get the 55.4 number. And then for the other type of calculator, when you go to one var stats, it might bring you here to the screen where it's going to want you to tell it what list to use. So you should have L1 there by default. If you don't for some reason, then just go ahead and type second 1, and that's going to type in L1 there. For the frequency list, just leave that blank. We don't want that there. And then you're just going to go down to calculate, click enter, and either way, you should get the 55.4. And one of us, either Dr. Insco or I, we might try to make you guys some extra videos with a little extra examples for how to do some of the stuff in your calculator. Okay, so that was the mean. Now we want to look at how you do the mean for grouped data. Okay, so this is where you have like some sort of frequency distribution that you're looking at. As far as the formula, X bar is going to be equal to the sum of each frequency times its corresponding midpoint. So that's what that capital X sub M stands for. That's just the midpoint of that category. And then it's still all divided by N. Okay, so let's look at an example. So example 2 says the data represents the number of miles run during 1 week for a sample of 20 runners. Okay, so we have this frequency distribution table given to us here. We know the class boundaries and then the frequency for each class. Okay, and we want to find the mean for those runners. So in order to do the mean, you have to figure out the midpoint of each one of those classes. Okay, so for the class of 5.5 to 10.5, Dr. Insco, how would you find the midpoint there?
The 10.5 plus 5.5 would give me 16, and then you would divide by 2 to get 8 for the midpoint?
Yes,
is that right?
That is exactly right. Yep, so you just add the lower boundary and the upper boundary and then divide by 2. Okay,
and we have widths of 5, so you can just add 5 to that. So you get 13 and 18 and so on?
Yep. Yeah, so how did you know that it went by 5s?
I was looking at the class size and I saw 10.5 to 15.5, so I just took that difference.
Yep, that works. You can also, like, if you first figure out like the first 2 midpoints, once you know the difference between those 2, then you can just carry that down. So they do go by 5, so we get 8, 13, 18, 23, 28, 33, and 38. Okay, then once you have your midpoints, you're going to take each one of those values and multiply them by the corresponding frequency. Okay, and that's going to go over here in column D. So 1 times 8 is 8, 2 times 13 is 26, 3 times 18 is 54, and so on. So the other ones are 115, 112, 99, and 76. Okay, so now we're ready to find the mean. So the sample mean, I'm just going to copy down that formula again there for you. So the sum, the numerator is just going to be the sum of that last column that we just did. So you're going to add up all of those values. And when you do that, you get 490. And then we'll divide by N. So they basically told us what N was like up in the description of the question. They said 20 runners, and then they also gave us the total frequency here. On Connect, it might not give you either of those. So if they don't explicitly say what the total is, and let's say they don't give you the total in the chart, how would you be able to find the total frequency?
You just sum up down column B?
Yeah. Yep, so you might have to take that extra step on some of the problems online where you actually add up all of those frequencies and that'll give you your total. So sometimes they give it to you, sometimes they don't. Okay, so we'll do 490 divided by 20, and that comes out to 24.5. So that's our mean there. Now you can also do this in your calculator. No matter what though, you do have to find the midpoints on your own. So whether it's completely by hand or with the calculator, you have to find the midpoints. Once you do that though, then what you can do is go back to your lists in your calculator. So stat enter, and you want to put the midpoints in L1 and then your frequencies in L2. Okay, so midpoints always go in L1, frequencies always go in L2. Once you have those values in there, you're going to go back to where we were before. So you click stat, go over to calc, and then one bar stats. And then here you're going to tell it to use both lists. So I think I actually have the calculators. Yeah. Okay, so on the 83 model, when you click one bar stats, then you're going to type in second one. That'll put the L1 there, and then you have to put a comma. So the comma is above the 7. So you hit the comma, and then you want to type L2, so you do second 2. And then click enter, and you should get 24.5. On the other calculator, your main list is your L1. That should be there already. And then your frequency list, you want to tell the calculator to use that. So you want to put an L2 in there. So you'll type or click second 2. That'll put an L2. Then go to calculate. And either way, you should get 24.5.
Cool.
So the second measure of central tendency is the median. And do you want to talk about that one?
Sure. So the median is kind of like the middle, like, right? Mean is like average, where you sum things up and then divide by the total number. And median is actually trying to say, like, find the middle value. And so this is really straightforward if n is odd, because what you do if n is odd is you just, well, in both cases, actually, you just lay out your data and you try to put it in ascending order. So like I would rewrite this list, which has 1, 2, 3, 4, 5, 6, 7, 8 values in it. And I would rewrite it from 25, and then the next value is 29, and 30, 30, 38, 76, 105, 110. And so then what I would do is on each side of this list, I would just start crossing out values. And if n is odd, then I'll just be left with one value in the middle. So if I had 7 values, then either 30 or 38 would have been left by itself. But since I have 8, I have 2 values in the middle. And so then once you've eliminated it down to 2 values, then what you do is you calculate the mean average of those 2 values, which is you add 30 plus 38 and you divide by 2, and that gives you the average value for 2 values. And this is a bad analogy, but I always use it. I say, like, how do you get the exact average value for 2 people? Well, you would take up, like, if I was going to get divorced or something, you would take everything my wife owns and everything I own, and then we would divide by 2, and that would give us our average value. So that's what you're doing with those last 2. So anyways, we get a median value of 34. So that's the middle value of this list, which is maybe kind of surprising because it starts with a 25 and 110. But when you look at the entire list of things, the middle value ends up being 34. Anything to add, Karen?
No, just that like their textbook and Connect will use the symbol MD for median. So if they see that, that's what that stands for.
And how do you calculate that using a calculator?
We're not going to tell them that yet.
Okay.
Yeah. We'll let them know that maybe later on. Maybe.
Okay. Sounds good.
Okay, so the third measure of central tendency is called the mode. So this is just the value in the data set that occurs the most. Okay, so usually like when you learn this in middle school, you're taught to associate the word mode with most. Okay, and a data set can have more than one mode or no mode at all. So if a data set has one mode, we call that unimodal. 2 modes is bimodal, and more than 2 modes is multimodal. So this is the easiest one by far to find. So for example, 4, if we want to find the mode of that data set, you're just going to look through and see if any of them occur more than once. Do you see what it is?
30?
30, yeah. 30 occurs twice. Nothing else occurs twice. So the mode is 30. Since there's only one mode, we would call that unimodal. Okay, if another value also occurred twice, then that just means that both of those are your modes. So you can have more than one mode. In a frequency distribution, we can also find the modal class, and that's just going to be the class with the highest frequency. So if you're given a table like this and you're asked to find the modal class, all you have to do is find the largest frequency. So for this example, it would be 5. And then, look over at what the corresponding class is, and that will be your modal class. So we would say the modal class is 20.5 to 25.5. And that's really it. So there's no like actual math to do there. Sometimes, like if you want to give one specific value for the mode, when you have a frequency distribution, then you could just state whatever the midpoint is of that class, but that's really optional, and you should be fine this whole semester with just stating what the modal class is. Okay, so just a couple extra things. The mode is the only measure of central tendency that can be used if the data is categorical. So if you were to hear a statistic like the average person prefers the color blue, well, colors are categories. So we obviously didn't do like any numerical calculation to figure that out. So that tells you that the mode was used in order to come up with that statistic. So average person prefers the color blue. That just means that more people preferred blue out of any other color.
Can I go on a little tangent?
Sure.
Okay, so I like to listen to a lot of podcasts, and one of them is the Indicator by Planet Money, and they spend like a week series talking about the quote unquote average American, and they say that like politicians and people in general use the term average American all the time, but the only one that really makes sense to use is really the modal American. Which type of person you most likely to meet on the street and have a conversation with. And so they did a whole series on like how these economists broke down all the different like socioeconomic classes and races, and they had to figure out what is the most common type of American. And I think they came up with two different ones. There was either like a baby boomer retiree woman aged like 60 to 70 with a certain income, and the other one was like a generations I think a generation X person, like a male that's like 45, a white male who's 45 years old in a certain socioeconomic class. I think it was like high school graduate with a little bit of college or no college education, but still making pretty decent money. Those were the two most common types of Americans as far as socioeconomic status and race and whatever else, education level. So that's my tangent. But I think it's funny because it's like we say average, and in this case, that's what we mean by average is what are you most likely to encounter?
Yeah, so that's a good point that like mean, median, and mode are all averages. So when you use the word average, you actually kind of don't want to use the word average. You want to be specific and actually state which measure you're using, because average is a really generic term.
Mm-hmm.
And actually, we're going to kind of do one more little example as far as that. So just to kind of highlight something. So let's just say that you had some sort of business where there are maybe like 3 employees and a boss or a CEO. And let's say that your 3 employees all make $10 an hour and the CEO makes $98 an hour. Okay, so according to this data set, let's look at some statistics that we could state regarding it. So let's say that I said the typical wage is $10 an hour. So is that true? And which measure of central tendency do you think I used to get that?
Mode?
Yeah, good. So that is true. And I use the mode to state that. So typical usually means like the one that's more likely to occur. So that would be the mode, which is $10. So that's true. Okay, how about this one? If I said half of the employees make $10 or less.
So I don't know, median or?
Yeah, so the median is the one that splits your data up in half. So when you calculate the median, it's telling you, that half of your data values lie below that amount and half of your data values lie above that amount. So that would be a true statistic that we got from the median. And then how about the last one? It says the average wage is $32 an hour.
So that would be the mean, where you added up all of them and divided by 4.
Yeah, exactly. Okay, so if you add those up, divide by 4, you get 32. So that would be the mean wage. Okay, so all 3 of those are true, but you can see that we clearly got one value that's different from the others. And what's the reason? Well, the reason is because this 98 value is what we call an outlier. So outliers are very high or low data values comparatively with your data set. And the point of this is that outliers affect the mean drastically. So if you do have an outlier in your set, then you might want to avoid using the mean to come up with statistics. In that case, usually the median is the better measure of central tendency to use. Does that make sense?
Yeah, it reminds me of a funny story about Georgetown University. I think like in 1984, the highest paid major that the university reported was art history, which confused a lot of people. And their average salary was in the millions, and people couldn't figure out why. And then they realized that there was only like 3 graduates in art history that year, and one of them was Patrick Ewing, who played for the Knicks. So like his signing bonus when he graduated was millions of dollars. So he was an outlier that threw that stat way off.
Yeah, so there you go. That's a perfect real life example there. Okay, so those are the 3 like main measures of central tendency. We do have one other one, a 4th one called the mid-range. The symbol for that is MR. And it's a very easy calculation. It's just the highest value plus the lowest value divided by 2. It's a very rough measure of central tendency because it's also susceptible to outliers. But that is another measure that you can use, especially if you just want to find like a quick measure. Okay, so there were those 4. Okay, do you want to talk about the weighted mean?
Sure. So a weighted mean, or I often call it the weighted average, but yeah, the weighted mean is just a sum where you assign weights to your different values or your categories, and then you weight each category, and then you sum up by the total number of weights. So here, the weighted mean x bar is just W1 times X1 plus W2 times X2. And in general, it's just the sum of the W's times the X's divided by the sums of the W's. So like, let's do an example of how you would do this to calculate your grade point average. Let's say that if you had a in a 3-credit English composition course, a C in a 3-credit introduction to psychology course, a B in a 4-credit biology 1 course, and a D in a 2-credit physical education course, then what you would do is you would take W1, which is 3 times 4, because every time you get an A, you get a 4 point. So that's 3 times 4, which is 12, plus 3 times 2, which is 6, plus 4 times 3, which is 12, plus 2 times 1, which is 2. And I'm not going to try and do that math in my head, but luckily we have that written down. And then we would divide by the weights, which is 3 plus 3 plus 4 plus 2, which is something I can do in my head. That's 6 plus 6 is 12, I think. And so let's see, that looks like that calculation is about a 2.666 repeating, which you could round up like 2.7. So that's your GPA for that one semester then. So this is the sort of thing that we do a lot. As teachers, we do a lot of this sort of calculation because we'll assign certain assignments, weights or point values, and then to get the grade at the end of the semester, we just do this weighted mean calculation. Is that good? Should I say anything about how you calculate this using a calculator?
Just that you can use the calculator if you want. You would actually do it the same way we did the grouped mean example. So what you would do is you would put the data values into your L1 list, and then the weights, those are basically like the same thing as the frequencies. Those are always going to go in L2. So the weights or frequencies is always L2. And then once you have those, you'll go to stat, calc, 1 variable statistics, type in L1, comma L2, or just tell it that your main list is L1 and then the frequency list is L2. And oops, either way, you'll get 2.7 as your answer.
Cool. And like you said, we'll probably make some videos explaining how to do this using the different technologies.
Okay, so one last thing for this section is just regarding distribution shapes and how the mean, median, and mode work with that. So if your data is symmetric, perfectly symmetric, then your mean, median, and mode are all going to fall in the middle of the data or the center, and they're all going to be equal to each other. Usually that doesn't happen though. So usually you have one of these two cases where your data is either positively skewed, which is the same thing as right skewed, or negatively skewed, which is the same thing as left skewed. So if your data is positively skewed or right skewed, then that means that the mean is greater than the median. And then vice versa for negatively skewed or left skewed. So when your data set is like that, that just tells you that the mean is going to end up being less than the median. So you might have some questions on Connect where you maybe have the graph, so you can tell visually how the skew is, and then you might be asked to compare, the mean with the median and just, state which one is larger. Or you might come across something where you have the data and you're able to calculate the mean and the median, and therefore which one is larger, and then that would be able to tell you how your graph was skewed. So without even graphing, just by comparing those two values with each other, you can figure out whether your graph is positively skewed or negatively skewed. Does that make sense?
Yeah, that's great.
Okay, so that's the end of section 3.1.